What up, what up? Another edition of Back to Basics. Let's see what we're getting into today. We've got exponential functions. Now, an exponential function is a function that increases at a much higher rate than a usual function. You see over here you have what would be a constant function. But an exponential function goes like that. It kind of curves up because it increases at a faster rate or decreases at a faster rate depending on what you're dealing with. Exponential functions look like that. A represents the initial amount. B represents the constant ratio. Okay, so that is how much you're basically doubling or tripling or halvesing or quadrupling or a thirding or something like that time after time after time again. And of course, our variable is x, and our variable is an exponent this time. So we're getting a little fancy, now. So basically, if you're going to look at these as a graph basis, they're going to look like one of four things. If A is positive and B is greater than 1, you're going to have a graph that starts flat and then curves upward. Okay? If A is positive and B is greater than 1. Now, B is never going to be negative in these cases, because if it's negative, then we're dealing with a negative to a third power, which is negative, a negative to a fourth power, which is positive. So we kind of go up and down a little bit when we're dealing with negative B's. So that kind of doesn't fall into the exponential form bracket. But if A is positive and B is in between 0 and 1, so like a fraction, it's going to look like this. Go like that and then flatten its way out. And if you're wondering why, it's because you already have a number, and say if it's between 0 and 1, say B is a half, you take half of it, half of it, half of it. So it gets smaller. If A is negative and B is greater than 1, sorry, I hit the pause button. If A is negative and B is greater than 1, we're going to have something that looks like this. And if A is negative and B is in between 1 and 0, we start from the bottom, just like Drake, and then we flatten our way out. So those are our four options. Those of you who want to memorize and try to understand what exponential functions look like ahead of time, we're going to focus on using a lot of charts, and then maybe as we do more and more and more of these, we kind of get the hang of things and we realize we don't need charts near as much. So let's move my face. Let's make me skinnier. And perfect. Put me up there. Graph y equals 3 to the x and list the horizontal asymptote. Now, that's one thing that we've never mentioned, so we'll save the horizontal asymptote for the end of the problem. But what we have is we have y equals 3 to the x. I'm going to make myself a table and see what we have. So I'll start out with 0, 1, 2, 3. So I'm going to plug in 0. 3 to the 0th is 1. Anything to the 0th is 1. 3 to the x is 1. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. So let's plot what we have. I have 0, 1. That's point number 1. I have 0, 3. So 1, 3. Did I say 0, 3? 1, 3, not 0, 3. I have 2, 9, which is right 2 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I really can't put 3, 27. But this is what I'm noticing. Every time I move right to the one to the right, I triple my value. 1 becomes 3, 3 becomes 9. So it would make sense that if I move to the left, I would 1/3 my value. Well, let's just make sure. If I plug in -1, this becomes 3 to the negative first power. 3 to the negative first can be written as 1/3. So what's 1/3 of 1? 1/3. So these guys get smaller and smaller. But this is what's going to happen, and we have to be careful because it's tempting to go down here, but that's not going to happen. If I have a positive number and I take 1/3 of it, it's always going to be a positive number. It's just going to be a small positive number. So when I graph this, I start out nice and flat, and then I skyrocket to the sky. And we saw from the previous slide, if I have a positive number in front of my parentheses, which I do, I have a positive 1. And if I have a positive number greater than 1 inside my parentheses, it looks like this. Now, what's all this asymptote talk? Well, an asymptote is where your graph flattens out. It's basically where you could say, well, my line is going to awfully get really close to that guy, but it's never going to hit that guy. Okay, my horizontal asymptote is going to be this, the x-axis. Now you might be thinking, all right, well, what about my vertical asymptote? You'll never have one because a vertical, so basically this line right here will never get lower than the x-axis. It can't, no matter what I plug in, none of these will ever be negative. So my horizontal asymptote is basically that green line right there. Now, a horizontal line is the equation y equals a number with no x attached. And in this case, since it happens at the x-axis, my horizontal asymptote is y equals 0. Okay? No such thing as a vertical asymptote because no matter what, I can always plug in another x value and get a really large y. So there's no line that I can draw vertically to say that my line's going to flatten out. It's not going to happen. Okay? Let's look at another. And we'll review this from a chart point of view. Okay, so it looks like I really also need to plug in negative. So I'll have 0, 1, 2, 3. And then at the very end, I'll deal with negative. Okay, so let's do this carefully step by step. If I plug in 0 to x, I get my parentheses to the 0th power is 1. So if I'm following PEMDAS, you deal with the exponent first, then multiply the number out here. So 1/2 to the 0th power is 1 times 2 is 2. Okay, 1/2 to the first power is 1/2. Then 2 times 1/2 is 1. Okay, 1/2 to the second power is 1/2 times 1/2, which is 1/4. And 2 times 1/4 is 1/2, or 0.5. So it looks like what I'm doing is I'm taking that number in here and I'm multiplying it to that guy every time. So this will be 0.25. By the way, what I just explained is exactly what I'm doing. Basically, the pattern is whatever number that is what you do to your dots as you move to the right. So the opposite is moving to the left. I'm going to multiply 2, but I don't want to view it that way. I just want to plug in -1. So if I have 2 times 1/2 to the -1. Okay, I take that parentheses only, and when you take a fraction to a negative number, you flip the fraction and now treat it like a normal exponent. So 1/2 to the -1 is the same thing as 2 to the +1, right? Or just 2. So last time I checked, 2 times 2 is 4. So if I'm multiply by 1/2 as my numbers get larger, I divide by 1/2 or multiply by 2 as my numbers get smaller. So let's plot what I know. -1, 4 lives right here. 0, 2 lives right there. 1, 1 lives right there. And then we get half the size, and then we get half the size, and we can understand what's going to happen. And just like last time, I'm never going to officially hit the x-axis. So if I divide by 1/2 going to the right, I multiply by 1/2 going to the left. So that 4 I can write here as an 8. I'm going to try my darndest to draw a really nice curve. I started out strong. I'm all right with that. Just like last time, I have a horizontal asymptote, and it's the x-axis, which means my horizontal asymptote is, again, y equals 0. All right, last one. Still going to make a chart. Even though I kind of feel like I understand what's going on, I'm still going to make a chart. I have x, I have y. I'm going to plug in -1, 0, 1, 2, and 3, if I can even make it that far. I think I can, because when you times by 1.5, it doesn't make it that much bigger. I'm going to start out by doing 0, so who cares to the 0th power is 1 times -2 is -2. 1.5 to the first power is regular 1.5 times -2 is -3. 1.5 squared times negative 2 is negative 4.5. Then the next guy is going to be negative 6.75. And when I plug in negative 1, you're going to have to trust me on this one. You're going to get, I think it's negative 4/3. It's negative 4/3, I think. Plug it in. Negative 1, negative 4/3 lives around there. 0, negative 2 lives right there. 1, negative 3 lives right there. 2, negative 4.5 lives right there. And 3, negative 6.75, that looks good to me. And then if you want to add a few more points, it's just slightly getting smaller, so there you have it. Let me start my horizontal line, and try to clean that up the best that I can. Oh, yeah. It's not pretty, but not impossible. All right. Exponential functions. You can do them making a graph. You can do them using common sense, but sometimes it's just more fun and easier to make a graph. And that's what I did 3 times. Thrice! Like a band. All right, this was fun. Bye!